Okay, welcome. We'll do a screencast today on a typical FRQ that comes all the time, areas and volumes. In this case, it was calculator active. It was the second calculator active problem in this year's exam, which is 2015. The mean for this exercise was 4.68 points out of 9, which was the highest of all 6 FRQs. The mean of all FRQs was 3.71 over 9. So that was the highest of all in 2015. Let's have a look at the entire problem and then we'll break it down into 3 questions and look at them one by one. So you have two functions f and g given here by rather complex expressions. F of x equals 1 plus x plus e to the power of x squared minus 2x, and g of x equals x to the 4th power minus 6.5x squared plus 6x plus 2. Two regions are defined between these two graphs R and S here, and we know the point of intersection 0, 2 here, and we know the point of intersection 2, 4 over there. We do not know the point of intersection here in the middle, and a typical mistake is to assume that it's 1, x equals 1. Question A is to find the sum of the areas between the two graphs, so the area R plus the area S. Second question, question B, region S is the base of a solid whose cross-sections perpendicular to the x-axis are squares. Find the volume of the solid. And question C, let h be the vertical distance between the graphs of f and g in region S. Find the rate at which h changes with respect to x when x equals 1.8. So let's start with question A, and we'll look at 3 students' work and comment on what they did and how many points they earned. The first students looked for the intersection point. Of course, he used, or she used, her calculator. F of A equals G of A, and they found that A equals 1.0328318883641. So kept many decimals because this is not the final answer. You want your final answer to be correct to 3 decimal places. So either you store the value of A in your calculator or you write many decimals. Now the area of R is here. It's the integral from 0 to A of G minus F. And then the area of S is the integral from A to 2 of F minus G. So for R, we have function G above and function F below, so we do G minus F. For region S, it's the opposite. F is above, G is below. And the student finds 2.004, which was correct. So notice the number of decimals. And the student earned 4 points out of 4. The first point was earned for writing the limits correctly, so from 0 to A, and here from A to 2. There was a point earned by being careful with the order of the functions. For region R, it's G minus F. Same for region S, it's F minus G, and then 1 point for the answer accurate to 3 decimals. One comment, you can find the area of these two regions, the sum of these two regions' area, also by doing it like that, using absolute values. This is F minus G. If you use the absolute value of F minus G, then you don't have to worry which region is above, which region is below. You don't even need to find the point of intersection. So that's a quick way to find the correct answer. However, you really want to know how to do that. You want to know how to put absolute values in your calculator. And when I tried, I realized that on the TI Inspire, if you're in the calculator part, the calculator cannot solve this expression. If you use the graphs and find an integral with the graphs, then you will find 2.004, which is the correct answer. Same thing on the TI-84. If you use the graph and integrate with graphs, you'll find the correct answers. But I don't think by using the calculator and the integral signs, the calculator part of the TI-84, I don't think you find the answer. So be careful. If you know that this works, great. But it might be just safer to go through the trouble of finding the intersection and then integrating from 0 to a of f minus g, or g minus f, and then integrating from a to 2 of f minus g. So the second student finds the value of a. Again, that student keeps many decimals. You will have a graph. You will have the graph on your answer sheet, so if you need to do work on your answer sheet, you can. We can see the student clearly labeled function g and function f. It's a very good idea. It helped being sure which function was above, which function was below. That student also indicates the value a. It's not mathematically correct. This is a point, so it should have 2 coordinates, but we get the idea. This is the x value of the point of intersection. This h here that you see is actually something that is related to question C. After that, the student finds the area of region R correctly. The student finds the area of region S correctly. Again, here it's G minus F, whereas for region S it's F minus G. And that's great. However, unfortunately, that student does not add these two values, so the student doesn't find the sum of region R and F. Notice something really important. Instead of copying what F is and what G is, which are really complex expressions, you can just write g of x minus f of x. As long as g of x and f of x are defined, and they are defined here and here, they could also be defined by you somewhere in the exercise, then that works. It's better, you'll avoid mistakes if you do it like that, and it's much easier to read too. So many decimals since it's not the final answer. Alright, so all the points, 1 point was earned because the limits from 0 to a and from a to 2 are correct. 1 point for this integrand, g minus f, and 1 point for this integrand, f minus g. The third student made a typical mistake of assuming this point is at x equals 1. So they integrated from 0 to 1 to find the area of R, and then they integrated from 1 to 2 to find the area of S, and this is incorrect. But the student earned 2 points since they did g minus f here, which is correct, and they did f minus g here, which is also correct. And also one last thing, oops, sorry. Even though he added 1 plus 1 and he got an answer of 2, they did not give him the answer point. So because there was a mistake earlier, they did not consider that it was okay to give the last point, even though the idea was right to add this value and that value. So let's move on to question B. Question B is the region S is the base of a solid whose cross sections perpendicular to the x-axis are squares. Find the volume of the solid. So region S is here. We're going to have to use F minus G. So F minus G will give us this length here. And if we want to find the area of a square, it's going to just be that value squared. Base times height, so the base is F minus G, the height is the same. This is the value of A that the first student defined in question A, so we can still use it. The cross-section area is f of x minus g of x squared. And then the student just integrated correctly from a to 2 of that function, and they got the right answer. So notice how the student, again, saves a lot of time by defining a function. He defines, or she defines, a of x equals f of x minus g of x squared, and then you just integrate a of x dx. So very good work, and they earned 3 points here out of 3. 2 points for writing the integrand correctly, and 1 point for the correct answer. By the way, in all these exercises, even if you follow what I'm saying and it seems easy, you need to do it with your calculator as well. You need to practice. Every time you take your calculator and you do it, you'll discover that there's something you don't really know, something you're really a little bit unsure of, and you don't want this to happen during the exam. You want to be unsure and uncomfortable before the exam when you practice, and when you get to the exam, you know exactly what to do with your calculator. Practice with your own calculator too. Exercise B for the second student, same thing. The volume is the integral from a to 2 of f of x minus g of x squared dx, and they get the right answer. Very short, very clear, 3 points. The last student, student number 3, kept on using 1 instead of the correct value of a, and then they kind of used something else. It looks like a pi of f of x squared minus pi of g of x squared or something, so maybe it's washers. The student also forgot the dx at the end, and that is just 0 points. So the student confused cross sections with cylinders or washers. Question C. Let h be the vertical distance between the graphs of f and g in region S. Find the rate at which h changes with respect to x when x equals 1.8. So if you remember h, a student had drawn this line vertical here and had written h, that was correct. H is this distance here between the two graphs, this vertical distance. So at x equals 1.8, we are almost at x equals 2. So the h is probably somewhere here. We can see that h is going to probably be decreasing at that point. The vertical distance between the two graphs is getting smaller and smaller as we approach 2. The first student found that if he defines a function h as f minus g, which is good, then the rate of change of h is going to be h prime here equals f prime minus g prime. And then earlier on he had calculated f prime, he had calculated g prime, so he plugs these values in and gets the right answer, and we can confirm our insight that the value would be negative. H is actually decreasing. If h had been somewhere here at x just after the intersection point, it looks like this vertical distance is increasing. It's bigger here, it's even bigger here. But at x equals 1.8, this vertical distance is decreasing. So 1 point for considering that h prime is f prime minus g prime, and then 1 point for the answer. So there were 4 points in question A, 3 points in question B, and 2 points in question C. That's 9 points. Our second student gets a little confused. It's a rate of change. Why would you integrate? F of x minus g of x is correct if he had written h of x equals f of x minus g of x, and that student did not earn any point. The last student wrote this line correctly. H is the difference between f and g. Therefore, the derivative h prime equals f prime minus g prime, and that earned him a point. After that, he did not get the right answer. So he got 1 point here, but he did not get a point for the answer. So some common mistakes that AP commented on were the following. So first of all, this is a typical area volume problem, and the only difference with the usual exercises we see sometimes and we will practice is that there's an upper and lower boundary curves that changes well, which function is above, which function below changes. So there are two regions R and S. So common mistakes in part A, students who consistently used the named functions f and g typically had very succinct, precise solutions. Some students guessed by looking at the graph that the point of intersection occurred at x equals 1. These students did not use the calculator. It also appeared that some students used the trace feature of the calculator to determine the point of intersection. That's not correct. You need to solve. You need to use more powerful tools on your calculator than trace. Some students found the area using an integrand with absolute value. So I showed you that, but if you want to do that, if you want to take that risk, make sure that you know exactly how to do it and when you can do it. It's probably safer to just go through the extra steps. It's more clear what we are doing. A common incorrect expression for the area was written here. I think there's two mistakes here. First of all, 1.033 is rounded to 3 decimals already, so the answer would already be wrong. And R is the name of a region. It's not the name of a function, so you can't say you're integrating R. I mean, you can say it. We sometimes say things, but we should not write it in an exam. And remember, writing f minus g and g minus f, or I think it was g of x minus f of x here and f of x minus g of x here, that earned you 2 points. So that student, just by trying to take a shortcut here, lost 2 points. In part B, which was the one where we were looking for the square cross sections, some students set up the correct integrand but included the constant pi in the final expression for volume. So just including a pi because we've used pi f squared of x a lot for cylinders, some students are confused when to use it and when not, and then they just mix the two methods. In part C, many students wrote h prime of x equals f of x minus g of x, which is incorrect. The distance between the two graphs is just h of x equals f of x minus g of x. It appeared many students did not have the use of the calculator when completing this part, or students did not know to use the numerical derivative capability. I see that in our tests as well. Some students, even though it's a calculator part, try to find the derivative by hand, and they get into big trouble because the expressions are huge and really complicated. Just solve everything with your calculator. These students often try to find the derivative of h analytically, and many made chain rule errors or could not evaluate the derivative at x equals 1.8. So things to think about. Now, some recommendations from AP students should use the names of the functions that are presented in the statements of the question. Teachers should model this technique in their classes and on student assessments. Similarly, students should store given functions in their calculator and use these stored functions instead of entering the function expressions multiple times. We can say this for functions, and we can also say this for points. If you find the point of intersection A, you can save this value in your calculator, and then you don't have to type 10 decimals every time. You just recall the value of A or the value of B, and it will have all the decimals. Students need additional practice on the method of finding the volume of solids with known cross-sections, especially problems in which the cross-sections are squares, rectangles, isosceles right triangles, equilateral triangles, or semicircles. So be aware, we'll do many of these, but make sure that you know when to use which kind of solution method. Thank you.